everybody, my name is Arila, and I'd like to walk you through my journey exploring voice recognition, speech-to-text, and other natural language processing APIs. So how many of you have experienced Alexa? Okay, Siri, Cortana. So how do you think is the technology that drives the magic behind those voice-activated devices and voice recognition programs today? Any guesses? Is it 10 years, 5 years, 30 years? How many people think it's 30 years technology behind it? It's close to 30 years technology behind it, and just now, with the cloud computing that's enabled by Google, by Amazon, and by Azure, that technology becomes feasible to the point that you can say, Alexa, what's the weather today? Or Siri, read my email. So that's, how do we get there? So those are actually the manifestation of the technology known as natural language processing. And recently what has moved forward is speech-to-text recognition and text-to-speech as well. But that is just the beginning. It's just like, being able to enable the software to hear and enable the software to produce sound. But how do you get to the actual understanding of the language? And that's where a lot of the race is on, like which bot to use, which cloud to sign up for. And it's very interesting how the different vendors of this technology have approached it and how far they have gotten today. So what I'm going to go over is a few generic use cases of what are the common problems that technologies try to address with this type of machine learning. How mature are these technologies? And we'll deep dive a little bit into what's available just on the speech recognition itself, and what we should consider as architects when leveraging technology like speech recognition and natural language processing. And I'll show you at the end a quick demo of playing with some of those APIs in Node-RED. Okay, that's what we're going to go through. So how did I decide to go into natural language processing? I actually have over 10 years experience with SAS Institute, and I worked at a small startup, Datagram, that was really focused on natural language processing, sentiment analysis, categorization, concept extraction, keywords matching, questions and answers. So those are like some really deep science behind it. It's driven by some of the most interesting algorithms like neural networks, hidden Markov fields, and whatnot. So it's like some deep expertise, very focused people. Usually requires tons and tons of documents to extract that knowledge, and also tons of training, tons of experts, domain experts, validating those models and going over and over and over again. So just 5 years ago, 6 years ago, when I last worked at SAS, we finished a product called contextual analysis. So I thought that was breakthrough, because it was like a magical, like you just pointed to a set of documents and extracts the topics for you and categorize them, so you can say, okay, so these are articles that deal with medicine, or these articles that deal with politics and so forth, and there's positive sentiment around it. We build a lot of products around that. Fast forward 5 years now. Everywhere you look, there is natural language processing, and it's becoming ubiquitous. With Alexa, with Google now, with Siri, it's becoming ubiquitous. What is different is that still for enterprise software, our day-to-day work, we're still hesitant to just like, have a conversation and that conversation being captured and interact with the software through our more natural way of interacting, which is how we interact with each other with a conversation. When we turn to our computers, we go to the keyboard, we go to the mouse, getting a little more comfortable with touch screens, but still that voice interface feels like we're not going to be heard, we're not going to be understood, and you add an accent to that, and it becomes almost impossible. So how do we get to trust the software, and where do we start? So it's on my journey of exploring the different APIs, what I found is that various vendors do different tasks better than others. So this is my personal opinion. I'm not paid by any of them. Just like my perception and evaluation of trying it out. Again, it's subjective to my accent as well. So from a natural language perspective of being able to have a very mature software, Google stands as the leader. So they have been on the forefront of machine learning in that space. And the one product that I consider their flagship manifestation of natural language programming is Google Translate. If you have experienced the way you can go between languages and how it understands and writes down on your iPhone what you just said, and you can see it immediately in Spanish or Russian or Hebrew, it's just amazing. To me, that's so magical. And what you can do with technology like that is automate some pretty boring workflows, like the ticketing systems that we all have to deal with. A ticket comes in, how do you triage it? There's a way you can do that with natural language processing, understand the urgency through sentiment analysis, do some categorization, and reroute it for processing with bots. Now, you would think that Google will also have the best bots. I'm not convinced. I think actually Microsoft has the best bots. If you want to play with them, the bot framework is there. They have focused on, have made huge progress in the question and answers types chatbots. You might have been bugged from various websites, like as soon as you log in and try an API, here comes a chatbot and asks you questions on how to help you with the API or help you navigate a healthcare provider. That's all chatbots these days. Very rarely there's actually a person until you get very detailed, very one-off question. So that's the other big use cases where there's a huge advancements based on natural language processing. And Alexa is a very interesting case that is actually very focused on, not so much on natural language understanding as much as voice commands. So it's really focused on how you interact through a system via voice. And it has a very interesting pattern that's different from the other APIs of the notion of skills and the notion of it's very event-driven. And it listens in the background. And that listening in the background actually creates challenges around privacy. So it becomes very interesting how much we want to trade off between what we consider private and what we consider convenience, and towards living in a magical world where everything works. And to put all this together, then it's making sense out of it. And for making sense out of it, I personally consider Watson's as one of the leaders around that, and they have put together recently a discovery service that allows you to define that context and environments and domain models for more understanding and bring data into applications. So that's like the high-level use cases. And then this is kind of like where is this technology on the maturity scale? So this is Arila's maturity scale. So how did I come with these colors and notations? So what you see in dark green is an APIs that already GA release have been around for a while. So that's why Google gets the most dark green. As you can see though, on the speech synthesis and the bots there in the yellow, it's just the beta technology. It's a beta technology, it just showed up like Amazon Transcribe just released like a couple weeks ago. It's in the yellow. And then if there's like a maturity or like, you know, significant advantages, I have marked them in green. So at a glance, what it means, I think the speech recognition APIs, natural language processing is really ready for us. The question becomes, are we ready for those APIs? And do we know what to do with them? And so it's like very interesting to go and look at all of these vendors, Google, Azure, AWS, Watson, have put enormous investment in providing examples, SDKs, REST APIs, whether it's synchronous, asynchronous, streaming to enable the functionality. However, what I see is challenging is they all have their own way of packaging these APIs and own way of designing the interfaces. So it's really more of a journey of like which one you want to go after. So I'll just give you, okay, actually back to this one. So for example, you can see like from a straightforward NLP functionality, we have speech to text, translation, the notion of extracting entities, intent, categorization, sentiment analysis, text to speech, bots, those are your question answer driven intelligence, and capability to build custom models. Custom models are needed whenever you want to make the software more accurate for a specific domain or specific person. And as you can see, everybody has their own idea of how to brand that. Amazon is, I love Amazon names. For text to speech, they have Amazon Poly, like a polyglot. For bots, they have Lex. Azure has Louis, language understanding, interactive services. So this, like, you know, Google is saying want to stay in classic natural language processing and speech to text. Watson is going through more like purpose APIs, like, you know, tone analyzer, Watson assistant as their bots and whatnot. So it's like really more of a like, where do I start? So I'm hoping this chart will help you where to start, depending on what you want to focus your software. And I just suggest just pick that vendor, learn about them, and you can always explore the others once you've experimented with the APIs with one of them. So it's really depends on what you want to do, how sensitive you are to the maturity of the technology, and what other relationships you have established with those vendors. Again, natural language programming does require a lot of compute And it does depend on other cloud services around storage, around security. So it's really not like you can just go diagonally and pick services left and right. Maybe in some cases you can, but it makes a lot of sense to consider the context of your relationship with current cloud vendors. And just another example of how involved the different cloud vendors can be. Just for speech recognition, which we have several, we have all four clouds offer that technology, Google and IBM being the most mature. Amazon just showed up, I think it's a pretty strong competitor, and Azure wins on price. And it's very interesting that if you try to analyze the pricing models, they vary. Like I show, like from 2 cents per minute, but what is that? Amazon is like, I don't know how they will track that per second, to 15 seconds increments by Google, to hourly rate by Azure. When you normalize it, you can see that Google Speech and Transcribe are the most expensive, followed by Watson and Azure. I think you pay for the accuracy. It's like really, it takes a lot to get to that level of accuracy, and I think it's amazing that for $1, less than $2 an hour, now you can talk to your software. So I encourage you to try it out. All of these vendors offer a free tier. So you can talk for an hour a month for free on any of those. Now you can see the challenge. Even if we get software through on the free tier, it really hits us on the day-to-day use with the price tag. It's kind of like evaluating the business case. Why do we need voice recognition? And just to highlight again the various considerations we should think about as architects is the complexity. What I see is the complexity of natural language processing, which comes natural to us. It's not natural to computers. A lot of research, 30 years plus, lots of open source in the space has been captured and packaged by all these vendors through increasingly better tools, more visual tools to use and leverage. So you are bringing complexity in one way, but it has been abstracted for you by the providers of those APIs. The other consideration is whether we want to do streaming or asynchronous. It really depends on how soon and how large is the information that you're processing. If it's simple things like the commands, that's mostly done streaming. If you want to do more elaborate processing like lectures, transcriptions and whatnot, then asynchronous makes more sense. Then how do you pick your voice commands? How do you train for that? Do you want to take into consideration recognizing voices, not just differentiating between speakers, but also whether you want to use voice as a type of identifier. For identification, Microsoft is the one that has that. Both Google and Watson, all others detect speakers, but not necessarily recognize the speakers. So there's additional work, like if you want to get Google to not only differentiate 3 speakers, but also that one of the speakers were Arila, we need to do additional training. While Microsoft they have that built-in coming up. Another challenge is custom models, how much the software works out of the box and how much you need to customize it. So customization comes two ways. One is customizing the voice models. This is like improving the recognition of the speech that's coming through the system. The other one is training the model to be more domain aware. And how far do you want to take the smart automation with bots? Personally, I really enjoy playing with the bots on Duolingo because I can learn Portuguese safely and make all kinds of crazy mistakes talking to bots. But at some point, I really, really want to get to that person to help me with my health claim and not go through 20 polite question and answers with a health bot. It's kind of think about the cases, like, how much we're automating and how much we actually want to keep that the people in the system as well, not just make the computers feel more human. And security and compliance, that is a tough area to figure out in this space. HIPAA and Alexa not friends yet. It'll be interesting. I think maybe at some point people don't care if Alexa knows that they have a chronic disease or suffer from diabetes, or that their grandmother passed away from cancer. But those Alexa is listening, and people forget to turn her off, and the computers are learning. So whether we consider it private or not, if the system is listening, it's learning. The good news is it doesn't really have intent to harm us. Okay, ouch. Running out of battery for my demo. So how are we all doing on time?
17 minutes.
Oh, okay, so let me run this before I run out of batteries. So what I'm using for demo is Node-RED. Node-RED. So Node-RED is another open software by IBM. It allows you to put together flows and patterns, like build like little programs that are stream-oriented with this little building block. So what I have put together, it has a library of, you can pull a library of nodes. So it had a lot about Watson. So my little demo leverages that. There were some nascent ones around Google, also Alexa, and some for Azure, but though I didn't get those to work. So I'll show you what I did get to work. So we have, you can do a few tests. So what we're doing is first we're going to go through this through injecting some happy text.
My name is Arila, and I am really happy to present a stunning demo to you SATURN 2018.
So this is how we can say it, speech to text. It did detect some positive sentiment. It detected a tone of joy. So you got to hear the British accent coming through the system. So another way is if I can also talk to it. So we can try to say something different. And again, it goes through speech to text.
So we can try to say something different.
And you can hear me say the same thing with the British accent. And we can also just to be more serious, there's a more difficult medical text I have in a file. So we can also get information through a file system.
Significant error to all insufficient spray can't be reliable for medicine insensitive staphylococcus aureus.
So now it becomes crazy when it gets into the more medical terms. This kind of illustrating why domain and training is important to be able to really get to that level of sophistication needed per domain, as well as just like general purposes. So you can see, like, from a sentiment analysis, so how do we know what to do when? So sentiment is like, we can detect the emotion, whether it's positive or negative, with some level of confidence, and it's doing pretty good there. And the tone analyzer helps you determine now which is the, I guess I don't know the values, which of the sentiment it is. So the sentiment is kind of gives a high score for whether it's a positive, negative, or neutral. There is some suggestions around tones. And then the tone analyzer is an additional level of sophistication that now says, oh, I'm more confident that it's joy versus fear versus annoyance, and so forth. So this it's interesting to play with it and kind of think of what you can do. I find Node.js is a good way of trying API side by side and running some hypotheses around the scores and find for yourself which one you want to pick moving forward. Or you can play directly with their websites. Google Speech API and analysis has a really nice website you can type right away. Same for AWS Comprehend. You can interact right on the website and compare or bring them into Node as well if your programming skills less rusty than mine. So that's what I have for you today. If you have any questions, I'd be happy to answer.
Let's start by thanking Arila for the talk. There isn't any microphone to go around in the audience anymore, so if you have a question, then I'll repeat it for the purpose of the video. Are there any questions in the audience, Linda?
Just to be clear, the code red,
Node-RED
provided all those analysis, the sentiment analysis, the tonal analysis, and all of the numbers that you showed. That was all done by Node-RED?
No, Node-RED provides the framework of being able to stitch an example, like I showed you. Those nodes are actually provided by Watson.
Oh, okay.
You can just, but they're free. Everything is Apache 2.0. If you have a Watson account, you can configure them. So I configured them with my account.
Okay.
But the technology is from Watson. Yes. So there's also nodes available from Azure. They're not as mature or not straightforward to configure. So again, it depends on how people interpret what they're doing for themselves. So it was very easy to work with the Watson ones. Maybe because IBM also is the originator of Node-RED as well. That's a framework that originally started at IBM, and it's open source Apache 2.0. And you can also add your own nodes. So it's kind of encourages you to build from existing functionality and provide bigger building blocks for what you need. And one nice thing about it, whatever you put here in Node-RED as a program, you can expose it as a service right away. It's not, so you go, like, that's why I like it as an architect, so you can go from a concept or prototype to an actual service in a very rapid iterations, getting input from the users, input from the different data sources. You can try and experiment and find what works well. You can test some hypotheses about performance or connections or latency or things like that. And once you have locked in the pattern, you can make a recommendation and take it to the next level through software engineering.
Thank you.
Welcome. Yes?
I assume that you observe certain dynamic in the development by the various vendors. Do you think that your table with the colors, the yellow, green, and so on, how long it will stay? But I'm trying to ask if, for example, half a year from now or a year from now, you would expect the same colors, or do you see some development which is improving?
So like I said, 5 years ago, there was very few leaders, and SAS Institute was the leader. Now it's very hard to tell, and it's every month there's a new service or a new feature to the service. Like for example, Google is just now adding to the speech recognition automatic punctuation, which is very important because it does transcribe it. If you notice, it wasn't putting periods or commas or those kinds of things. So it's very hard. Okay, so yes, it understands, it can repeat it back, but can I put it into a document? Will it change the meaning if a software tries to interpret where to put the punctuation? So I see really an opportunity to start using this technology, providing feedback, thinking creatively about it. And within a year, I think we'll be all green. It will be a price war then, hopefully. So we get all 50 cents across the board or less for this type of technology.
Actually, I have one question more to make it also to this gentleman's from Fraunhofer Institute. Have you observed a lot of the UX activities in the speech recognition or the use of speech?
Of course, you see more and more that people are using this. And as for myself, I'm a power user of Siri, and it's getting better and better. I would love to have the automatic punctuation here because when I now have to speak on an answering machine, I usually use the Siri talk there, like period and comma and everything. It would be really great to have this there. And we see it's accepted and accepted more and more. Especially in Germany, of course, we have all these security considerations, when we're talking to the machines, because machines now know everything about this. But I guess from the experience of doing it, it's very well received.
Yeah, I think it opens some philosophical questions. Are we putting ourselves through too much scrutiny to try to solve all the problems with technology versus, say, through policy? I think it's opportunity to look at how do you protect privacy without having to encrypt everything, lock everything, be suspicious of everybody. Just how do you really think differently about protecting privacy so we can leverage this technology closer to the way we think and we interact with humans. Just have this enormous brain power behind us that never ages, never gets tired of looking at the same things and learning 30 languages plus when maybe I can learn 5. But now I can speak through Google Translate 120 languages. It's pretty powerful. One question.
One way to take. Do you have Siri or Apple on your grid or whatever?
Well, Siri is actually powered by Nuance, I think, and Nuance leveraged by Watson. So it is kind of, in a way, you got to see that. It's a little detective work of tracing them back, but these are the 4. Google, Amazon, Watson, and Azure. All roads lead there. And again, if you want to be super, super accurate, then you talk to SAS. They do have the best models when you want to get into the real high accuracy, like above 90% across the board.